Hi, welcome to ExamPadi. Our topic today is LCM and HCF of whole numbers. In this lesson, we will 1. Define factors and multiples and show their relationship. 2. Explore prime factors, LCM and HCF. And 3. Solve simple examples on LCM and HCF. What do you understand by factors and multiples? When two or more smaller numbers multiply to give a bigger number, these smaller numbers are called factors of the bigger number. In another sense, a factor is a number that can divide another number without any remainder. Examples: the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. While the factors of 50 are 1, 2, 5, 10, 25, and 50. What then are multiples? This is the product of numbers or factors that give other numbers. Thus, 24 is a multiple of 1 24 times, a multiple of 2 12 times, a multiple of 3 8 times, a multiple of 4 6 times, a multiple of 6 4 times, and a multiple of 8 3 times. The relationship between factors and multiples are closely related in mathematics. The multiples of a number are all greater than or equal to the number, while the factor of a number are all less than or equal to the number. In a nutshell, when looking for factors, you are dividing, and when you are looking for multiples, you are multiplying. These concepts are fundamental in many areas of mathematics, including fractions, ratios, and algebra. Prime factors of numbers. Prime factors of a number are the factors of that number which are not divisible by any other number except that number and 1. For example, the prime factor of 30 are 2, 3, and 5, because out of all the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30, it is only 2, 3, and 5 that are not divisible by any other number except themselves and 1. Examples: write the factors of the following numbers and state the prime factors. Hence, express each number as a product of its prime factors. A. 22, B. 50, C. 63, and D. 42. Solution. Factors of 22 are 1, 2, 11, and 22. The prime factors of 22 are 2 and 11. Product of its prime factors are 2 multiplied by 11, which will give us 22. B. 50. Factors of 50 are 1, 2, 5, 10, 25, and 50. The prime factors of 50 are 2 and 5. Product of prime factors of 50 equals 2 times 5 times 5, which equals to 2 times 25, and that gives us 50. C. 63. Factors of 63 are 1, 3, 7, 9, 21, and 63. The prime factors of 63 are 3 and 7. Product of its prime factor are 3 times 3 times 7, and that is 9 times 7, which gives us 63. D, which is the last one, 42. Factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. The prime factors of 42 are 2, 3, and 7. Product of its prime factor are 2 times 3 times 7, and that gives us 42. Let's take a look at prime factorization. Examples of prime factorization are A. 27, B. 104, C. 116. How do you find the prime factorization of a particular number? Here we are going to be applying the index form. Solution: divide each of the number by the prime factors in turns until it will not divide any further. It simply means that you start with the lowest number. A. 27. The first number we'll be dividing 27 by is 3, because that is the lowest number. 3 in 27 gives us 9. 3 can still go in 9. 3 in 9 will give us 3. And 3 in 3 will give us 1. If you multiply all our prime factors, we'll have 3 multiplied by 3 multiplied by 3. And that gives us 27. B. 104. The least number we'll be using to divide 104 is 2. 2 in 104 gives us 52. The next number that can also divide 52 is still 2. 2 divided by 52 gives us 26. Also, 2 can still go in 26, and that will give us 13. Of course, as we know, 13 is the only number that can go in 13, and that gives us 1. 2 multiplied by 2 multiplied by 2 multiplied by 13. That will give us 104. But that is not where we are going. Our prime factors there are 2 raised to the power of 3 multiplied by 13. C, which is the last one, 116. 2 in 116 gives us 58. 2 in 58 gives us 29. Of course, 29 is the only number that can divide 29. 29 in 29 gives us 1. That is 2 multiplied by 2 multiplied by 29. That is equals to 2 raised to the power of 2 times 29. Let me take you back to your primary class. The least common multiple, also known as LCM, of 2 or more numbers is the smallest number that is a multiple of all the numbers. The multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. The multiples of 3 are 3, 6, 9, 12, 15, and so on. Notice that 6 and 12 are the common multiples of 2 and 3, but the least common multiple is 6. Another example is find the LCM of 22, 30, and 40. Let's take a look at this method. Express each number as a product of its prime factor. For 22, the prime factors are 2 and 11. For 30, the prime factors are 2, 3, and 5. While for 40, the prime factors are 2, 2, 2, and 5. That is, you have 2 raised to the power of 3 and 5. Therefore, we can say the prime factors of 22, 30, and 40 are 2, 3, 5, and 11. The highest power of each prime factor must be in the LCM. These are 2 raised to the power of 3, 3, 5, and 11. Thus, the LCM equals 2 raised to the power of 3 multiplied by 3 multiplied by 5 multiplied by 11, which gives us 8 multiplied by 3 multiplied by 5 multiplied by 11, which equals to 1320. Let's try out some quantitative aptitude tests on LCM. For example, 2 raised to the power of 3 multiplied by 2 raised to the power of 3 multiplied by 7. Highest common factor of 2, 3 or more numbers. The highest common factor, also known as the greatest common divisor, is the largest number that divides 2 or more numbers without leaving a remainder. Let's take a look at a few examples. Find the common factors of 42 and 70. Solution. The factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42, while the factors of 70 are 1, 2, 5, 7, 10, 14, 35, and 70. The factors common to both numbers or found in the two lists are 1, 2, 7, and 14. The highest of the common factors here is 14. Hence, the highest common factor of 42 and 70 is 14. Example 2. Find the common factors of 18, 27, and 36. Solution. The factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 27 are 1, 3, 9, and 27. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Their common factors are 1, 3, and 9. Thus, their highest common factor is 9. We have come to the end of today's lesson. Here are a few questions to evaluate yourself. 1. State the difference between factors and multiples with examples. 2. Provide the full meaning of LCM and HCF with definitions. 3. Write out the factors and multiples of 12, 16, and 24. 4. State the least common multiples of 15, 20, and 25. 5. Find the HCF of 24 and 36. 6. Factorize these numbers to their lowest common multiples. A. 90, B. 36, and C. 448. 7. Factorize these numbers to their highest common multiple. A. 28, B. 36, and C. 24. Thank you for learning about LCM and HCF of whole numbers with me. See you in our next video. Bye.